Before getting into actually writing any of the code or doing the lab, I'm just going to do a quick walkthrough of this base project here that I've provided to get you started on doing the lab so that you have an idea of the code that's already there, how it's structured, and how you're going to fit in the pieces that you need to work on. One thing that's going to be obviously different at the very beginning from the games and projects that we've done in the past is the scene is actually completely empty at the start, and we're going to be generating it as the game is running at the very start of the game. And I'll show that before I go into the code, because if I click the play button here and start the game, it generates the Pac-Man board, and you can see it here. It's all ready to go. How is that happening, though? We can take a look at the prefabs here. I've got a bunch of different tile prefabs that define all of the different components that can potentially go into a board. And we can walk through those. So here we have a corner tile, for example. It's just a simple dot. Interior tiles are blank tiles that aren't going to have anything on them and shouldn't be reachable. Pellet tiles have this little white pellet dot that's collectible for Pac-Man. Start tile is going to be one of the more important ones. So this is where the actual player controllable Pac-Man object lives. It's inside of the start tile. And looking at the structure here, underneath the start tile, I have this player object that in turn has a sphere. That's the very simple model that I'm using for Pac-Man for the purposes of the lab. This has the player script attached to it already. So that's where you're going to be writing code for the first part of the game is in the player script. Just know that it's already applied to this, and as long as you're only ever instantiating a single start tile in your game, Pac-Man will be there, it'll operate, and it'll use the code that you write inside of the player script. The last one's simple. It's just a wall tile. It can be oriented vertically or horizontally to draw the lines of the board. So I'll run it again just to show you what it looks like. So there you go. You can see we've got some corner tiles up in the corner here. We have the start tile that I've placed on the left and various walls and pellets to configure a Pac-Man board. Why is it structured this way? If we actually go look at the code, so here's the code that I've provided at the start of the lab. And one of the things that exists is there is a folder for levels, and inside of that I've put one starter level called level 1. And this should look somewhat familiar. It's just an ASCII representation of that board that's being generated for you. Level 1 inherits from level. So I'll probably do a separate video talking a little bit more in depth about inheritance and how you would use that. But for now, just keep in mind that level 1 is inheriting from level. It's a subclass of level. And in level, there is this build level method. You're not really going to need to worry about the contents of this too much. You shouldn't have to change them unless you decide to get more advanced and try to come up with new ways of generating game boards, but that's not a requirement of the lab. Just know that this exists, and inside of the level class, there's a build level method that takes the string definition here and constructs a game board for you. So later down the road in one of the future videos, we'll talk about adding additional levels. You'll make a level 2, a level 3, and you'll be able to just copy this and type in different sets of these string characters to represent the game board, and it'll automatically generate that for you. What else is going on? We have the tile class. This is a script that's being applied to all of those different tiles. So actually, if we go back to Unity just to show that that's the case, you can see each one of these has a tile script on it. There's the corner tile, there's the interior, even the start tile has it. The important part being that each tile has a record of all the tiles that are adjacent to it. It has a right, a left, an up, and a down. It also has a type, whether it's open or blocked. So you can assume generally that pellet tiles and the start tile are open tiles, any tile that you're allowed to move to. That's all handled in the level generation portion of the code. And it's got a method for is open so that you can check, is this a tile that I am allowed to move to? That's going to be useful when writing your player script. Other things. I've already prepared for you this base character class. And because one of the early focuses of this lab is on inheritance, the character class is what you're going to be inheriting from for all of the components that are moving within your game. In this case, Pac-Man and the 4 ghosts. And you can tell that character always has a target and it always has a previous. So the target is what tile it's currently moving towards, and the previous is the tile that it just came from, which should give you all the information you need to know to decide where your character is going to move next. The update function is also implemented for you. It's always setting the transform, it's taking the position, and it's moving it a certain distance towards its current target destination. So if you give it a new tile to target, it's just going to slowly move towards that tile. What this means is that since you'll inherit from it in Pac-Man and all of the ghost tiles, all you'll really need to do to get them to move properly is call the set target method to set whatever tile they should currently be moving towards. And they're going to have different rules for how that's going to happen. So your player will set a target based on where it's located and what keys you're currently pressing. The ghosts will all have their own rules about what their new target is going to be. They'll reach an intersection and need to decide, do I turn left? Do I continue straight? Do I go up? And they'll have various different ways of deciding that based on where the player currently is, maybe based on where the other ghosts are. But the key point is that because you'll be inheriting from this character class, all you'll need to do is write the custom logic for those and call set target, and they'll all automatically move. So that's the intention for the structure of this project. And finally, the player class is already here for you. As you saw, I applied it to the Pac-Man model, the game object within the start tile. So this is what will be running. At the moment, it's just calling base.update. So as I mentioned when talking about character, player inherits from character. And so I'm overriding the update method. Again, I'll talk about that a little bit more in the video on inheritance, but we've got this virtual keyword appended or prepended to the update method on the character class saying our child class is going to override it. And then in the player class, we are overriding that update method with the override keyword, and then calling base.update, which means before any of the code that we write within this class, it's going to go ahead and execute the update method from its parent class. So one last time, coming back over to our base game scene and running the game. Here you go, here's our board. And to show that the code that I've already written for you has done a lot of this wiring up, if we actually go look at our scene a little bit, and for example, take a look at one of these tiles, maybe this pellet tile right here. That pellet tile has a right, a left, an up, and a down. The level generation code has actually created that for you. It's done all of the linking between those, and you can tell this is an open tile. It's one that they're allowed to move to. If instead, for example, I were to click on this tile to the left of it, which is a wall, as you can see on the board, it's right there. It also has all of its neighbors linked, but it's a type blocked. So because this is a wall tile, you'll never be allowed to move there. So you're going to be able to use that type checking and the isOpen method to determine whether or not your character can validly set it as their new target. And last thing is there is a level manager script already in here for you. This level manager is one of the only things, in fact, it's the only new game object besides the default camera and lighting. And it just takes in all of the different prefabs that you're looking for. Later, we'll make some changes to this to add more levels than one, but right now at the moment, all it's doing is it's setting all of the prefabs, and then it is creating a new instance of that level 1 class, and it's building the level, which should set the game up to run for you. And that about does it for the intro to the project. One thing, if you are one of my students in the current semester as of when I'm recording this, which is spring 2021, I've made a few small tweaks to the script. So if you're later than that, you probably don't care about this last piece. But to make things a little bit easier after using that first class as a guinea pig, the main change is that this tile is no longer maintaining game objects as its adjacent tiles. It's now directly grabbing the tile script, which is just going to simplify a little bit of the code you wrote. If you're in that class, I added a V2 folder in the class drive that has the updated scripts. So up to you if you want to use the new version or stick with the version you're already familiar with, but it's there if you choose to use it. And next video will be on writing the code for the actual player movement.